So, a very quick run through on cerebral autoregulation. So, the two theories of cerebral autoregulation are the myogenic and the metabolic theory. With the myogenic theory, we have vascular smooth muscle, and this responds differently depending on what's going on in the body. So, for example, in exercise, when we have a raise in blood pressure, there's cerebral vasoconstriction in order to limit the cerebral blood flow. In comparison, when we have hypotension within the body, there will be cerebral vasodilatation to increase cerebral blood flow. And then we have the metabolic theory. So in the metabolic theory, we have products of cerebral metabolism, which include hydrogen ions, potassium ions, nitric oxide, and adenosine. And these products of metabolism are produced as a result of cerebral metabolism. And when these products are increased, there's local vasodilatation to increase blood flow to meet the metabolic demand of the brain. These two diagrams here are common diagrams that we need to recognise. So this diagram here shows on the y-axis cerebral blood flow in mils per 100 grams of tissue per minute, and on the x-axis with the mean arterial pressure. This is showing that between a mean arterial pressure of 50 and 150, cerebral blood flow can be maintained at 50 mils per 100 grams of tissue per minute. Above and below this map of 50 and 150, we have a fall in the cerebral blood flow when there's a map less than 50, and an exponential increase in the cerebral blood flow with a map above 150. We then have this diagram here, which shows the changes in cerebral blood flow in response to the arterial PCO2 and PO2. So, at a PaCO2 value of 5 and below, cerebral blood flow is fairly constant. Above a PaCO2 of 5, there is a rise of the cerebral blood flow, as we can see on the diagram here. This is why in head injury patients, it's important to keep the PaCO2 between 4.5 and 4 in order to prevent fluctuations in the cerebral blood flow. And this line here is showing the effects of the PaO2 on cerebral blood flow. And as we can see, up to a PaO2 value of about 7 and above, there is maintenance and no changes in the cerebral blood flow in terms of change in oxygen concentration. However, below a PaO2 of about 7, there is an exponential rise in the cerebral blood flow. And this is a mechanism to try and increase the cerebral blood flow in order to increase the oxygen supply when there is a deficit of oxygen within the blood. I hope this all makes sense. It was a very quick overview of cerebral autoregulation.